This is the independent practice for 8.2, talking about some function rules, and hopefully you've had a chance to do this. This is, we need to find the function rule for the sequence, and then it wants us to find the value of the 12th term in the sequence. So, from position 3 to the value of the term, I could say it's plus 9. And that works for each of them. Okay, so 3 plus 9 is 12. 4 plus 9 is 13. 5 plus 9 equals 14. Now, at first I was looking at this and I thought 3 times 4 equals 12. But 4 times 4 is 16, so that didn't work. You got to find something that works for each one so that I have a consistent function of what goes in and what comes out. Okay? So let's see, the value of each term is find the value of the 12th. So the idea here is that we're doing n plus 9. So if I want this to be the 12th term, it's going to be 12 plus 9, and that's going to equal 21. So it's going to be 12 and 21. Alright, let's look at the second one. What's going on from 2 to 24, 3 to 36, 4 to 48, 5 to 60? Let's see, is it being added by 22? Nope, because that wouldn't work for this one. Let's see, times 12. Let's see if it's times 12. 2 times 12 is 24. 3 times 12 is 36. 4 times 12 is 48. 5 times 12 is 60. So it's, oh, I guess we're using n. 12 times n. Now, it said, what is the 12th term in this one? If the position is in the 12th term, what is my value? 12 times 12 equals 144. Alright. Let's look at number 3. Describe the relationship between the terms in the sequence 6, 18, 54, 162. I know from 6 to 18 is times 3, and 18 to 54 is times 3, and 54 to 162 is times 3. Okay, so I figured out the formula is times 3 times the number before. So 6, 18, 54, 162. Now I need 1, 2, 3 more terms. And this is going to get pretty big, so I'm going to use my calculator in this. 3 times 162 is going to be 486. 486 times 3 is going to be 1458. And 1,458 times 3 is 4,374. Okay, so the relationship in this sequence is times 3. It is a geometric sequence. Okay, number 4, we got to pull it out so we can see the table. The table shows the amount it costs to rock climb in an indoor rock climbing facility. Based on the number of hours, what is the rule to find the amount charged to rock climb for X hours? Okay, so what's going on here? Looks like plus 8. From 21 to 29, plus 8. And from plus 8. So each time I go up, I get another 8. So if I go 1, it's 8 hours. 2 is 16. 3 times 8 is 24. So part of the function is x times 8. Okay. Now, if I do that, 1 times 8 is 8. What else do I need to do to get to 13? I need to add something more, and that is going to be 5. So I think my function is going to be 8x plus 5. Let's see if it works for 4. 8 times 4 plus 5. 8 times 4 is 32, plus 5, 37, and that's what I got in the output, 37. Okay? So I see that I was adding 8, which meant that, multiplication is just repeated addition. So every time I get another 8, go a little higher. So it's just times 8. 1 times 8, 2 times 8, 3 times 8. Okay. Let's look here at number 5. Determine how the next term can be found, and then find the next 2 terms. Okay. So what's going on here? Is it times 4? 4 times 4 is 16. 16 times 4 is 50. Oh, that's not right. Doesn't work. So let's go with addition, because I know I'm getting bigger. It's either going to be multiplication or addition because I'm getting bigger. So I'm going to try plus 12. Plus 12. That works. 28 plus 12 gets me 40. Okay, so the rule is plus 12. And then I need to find 2 more terms. 40 plus 12 is 52. 52 plus 12 is 64. Okay. Now, number 6. Again, I know I'm getting bigger. So it's either going to be adding or multiplying. Now, 1.5, I'm going to start by adding how much it takes and see if that works. So 3.9 minus 1.5, that's 4. Okay, so if I add 2.4 to 1.5, then I get 3.9. Now let's 3.9 plus 2.4. 3.9 plus 2.4. 9 plus 4 is 13. Bring my decimal down. 7, 8. Oh, that's not it. That is not it. I don't get 6.3. Oh, yes, I do. I know it's it. You're wondering why did I put the 4 here when it's 2.4? Okay, let's try that again. 3.9 plus 2.4. Okay. I knew multiplication wouldn't work. I had a feeling about that. So, when this didn't look like it worked out, then I had to see if I did everything correct. And I found out I didn't. I put the wrong digit down there. 9 plus 4 is 13. Bring my decimal down. 3 plus 2 is 5. Plus 1 is 6.3, which is right there. And then if I add another 2.4 to 6.3, 2.4, that gets 7. Bring my decimal down. 8.7, which is right there. Okay, now I need the next 2. So 8.7 plus 2.4. Close there, put my decimal down, and that's 11. 11.1, and then add another 2.4. That gets me 5. Bring down my decimal. 2 plus 1 is 3. 1 is 13.5. Okay. Now let's go here. I got fractions. But the cool thing about this fraction is that all the denominators are the same. That helps me. So I have 2 1/4, and I'm going up to 2 3/4. It's not multiplied, it's adding something. and it's not adding a whole number, it's going to add a fraction. So how do I get from 1/4 to 3/4? I add 2/4, or 1/2, but let's add 2/4. So then, if I do 2 3/4 plus 2/4, that gives me 2 5/4. And if I want to change that, well, you know what? I'm going to do it simpler. I could change that into 3 1/4, but let's make this into an improper. 4 times 2 is 8, plus 3 is 11/4 plus 2/4 equals 13/4. How many times does 4 go into 13? 3. 3 times 4 is 12. Leaves me with 1/4 left over, which is that number. Okay, so it's plus 2/4 plus 2/4. Now, I need to get 2 more in the sequence. So 3 3/4 plus 2/4. Change this into an improper. 4 times 3 is 12, plus 3 more is 15. 15/4 plus 2/4 equals 17/4. And when I do that, I know 4 goes in there 4 times. 4 times 4 is 16. Leaves me with 1/4. 4 1/4. 4 1/4. That's the next one. And then we want to go one more. Let's see what one more is. Okay, 4 1/4 plus 2/4. We'll make this into 17/4 plus 2/4 equals 19/4. How many times does 4 go into 19? Goes in there 4 times. 4 times 4 is 16. That leaves 3. So it's 4 3/4. That would be the next one. 4 3/4. Okay. Let's go. Oh, now we just need to find the missing number. Number 8. Alright, so the missing number, I see that I start here at 30, missing some number, 19, 13.5. So it's going down. And I'm going to say it's subtracting. So I'm going to look at these two right here, find out what the difference is, and then I can do 30 minus whatever we find here. Okay? So 19 minus 13 1/2. Make that into fractions. 19/1 minus, let's see, 13 times 2 is 26, plus 1 is 27/2. But with minus, I need the same denominator. And I know 2 will work. So this is 38/2, and this is 27/2. Now I can minus it. I know 2 is going to be on the bottom. 38 minus 27 is 11. And then how many? That can't be right. Oh, yes, it can be. I'm not finding the number that goes in here. Sorry, that was a brain freeze for a minute. So now 11/2, how many times does 2 go into 11? 5 times, 5.5. So 5.5 is what is being subtracted every time, or added. If If I'm going this way, it's adding. If I'm going this way, it's subtracting. So I'm going to start at 19. 19 plus 5 and 1/2. So 19 plus 5 is 24, and then I have my half. 24 and 1/2. So it's going down by 5.5. This way is minus 5.5. This way is plus 5.5. Okay, let's keep going. Number 9. Decimals. So I'm going from here to here, which is going from a little bigger to smaller, so it's subtracting something. 43.8 minus 36.7. Subtract this out, that's 1 minus that. 3, that's 6, 7.1. So I think it's going down 7.1 each time. So let's try it. 36.7 minus 7.1. 7.1, that's 6. Bring down my decimal. 2, 1, that's 9. 29, and you can use your calculator on this. 29.6. Now, if 29.6 minus 7.1 gets me here, then I know I've got the right function. 6 minus 1 is 5, bring down my decimal. 9 minus 7 is 2, bring down my 2, 22.5, which is exactly that. Okay? So the rule is minus 7.1. Alright, now I do want to go to the next page. We have 3, I think we have 3 or 4, 4 more. Okay. Let's do these. We want to state whether each sequence is arithmetic or geometric. Remember, arithmetic means that it's adding, and geometric means that it's multiplying. Okay. So I go from 1 to 6. I'm either adding 5 or timesing by 6. If I add 5, 1 plus 5 is 6. 6 plus 5 is 11. Nope. Let's multiply by 6. 1 times 6 is 6. 6 times 6 is 36. 36 times 6 is 216. So for this one, it is geometric, and it says find the next 2 terms in the sequence. So 216 times 6, 36. 6 times 1 is 6, plus 2 is 8. 1286. Then if I use my calculator, 1286 times 6, I'm going to get 7776. Okay? Alright, so let's go on to the next. We have to see if it's adding or subtracting. And it looks like we're getting bigger. I mean, adding or multiplying. We're getting bigger. I want to suggest it's adding, because we're going from 0.75 to 1.75 to 2.75 to 3.75. I know I'm not multiplying. Looks like I'm just adding 1 every time. So I'm going to say this one is arithmetic. Arithmetic. Okay, and what we're going to do is we're going to add 1 to the next. So 3.75, add 1 is 4.75. Add another one is 5.75. Adding 1 every time. Okay. Let's look at number 12. We know we're not multiplying because anything times 0 is going to be 0. And we're getting bigger, so it must be adding. 13 plus 13 plus 13. Yep. So the rule is to add 13. So 30, which means it's an arithmetic. And the next two terms would be 39 plus 13. That equals 52. And then after that, it's 52 plus 13, which is 65. Okay, there you go. Now, we have one more, and then we'll be done with this independent practice. Number 13. Jay is stacking cereal boxes to create a store display. The number of boxes in each row are shown on the table. So for one row, he has 4 boxes. 2 row, he has 6 boxes. Is the pattern an example of a arithmetic sequence or a geometric sequence? Explain. How many boxes will be in the 5th row? Okay. So, let's see. 1 box gets me to 4. 2 boxes get me to, or 2 rows get me to 6. So let's see. The sequence is every time we add a row, we go plus 2, plus 2, plus 2. Okay? So when anything is plus 2, it's an arithmetic sequence. And what would be number 5? So if 4 is 10, 5 is 12. Okay. All right. Go ahead and let me know how you did. And then you can do some extra practice. And if we have any questions, we can keep working on it.